Salutations, mini mathematicians. Thanks so much for being here. We started 4.2C lesson on Amplify last time, and I just want to go over really quick. If someone was absent and they need to copy down the lesson purpose, this is here. Remember, we always want to write our variable in front, so if we have to switch our sides, we have to flip our symbol. If 5 is greater than x, then x is less than 5. And we also looked at when we might have no solution, and this is how we would graph that. It is intentionally left blank. I guess I could put 0 on that number line. It is intentionally left blank. And then we also, of course, looked at if there was all real numbers, where we have our number line and then we graph all real numbers. We don't say infinitely many solutions with inequalities because every solution set has infinitely many. So this shows all real numbers. Perfect. So we're going to look at that handout that you were provided in class, and we're solving and graphing multi-step inequalities. So we're going to consider the following two inequality statements. This is a compound inequality. When x is less than or equal to 2 and 2 is less than or equal to x. So in our own words, describe the solution set for each and draw the graph of the solution set. Well, if we take a number line and we put 2 on it, and of course we always graph one integer above and one integer below, and we think about x is less than or equal to 2, that's going to be a closed circle at 2 and shaded to the left. And if we look at 2 is less than or equal to x, well, if we switch the sides, we flip our symbol, that means we'd have a closed circle at 2 and we're shading to the right because x is greater than or equal to 2. What does this look like? Well, that means our graph would look something like this, meaning I have 2 and all the numbers above 2 and all the numbers below 2, which means this answer is all real numbers. So another example of not infinitely many solutions because we're dealing with inequalities, but all real numbers. So we are going to do the odds together. You're going to go back and do the evens. We already did one on Amplify together, so we're going to skip it. It's on Amplify. We already did that last class. So I'm going to jump to number 3. Taking a look at number 3, our goal is still the same. We still want to isolate that variable. So I'm going to multiply both sides by 3. You can think about that as 3 over 1. And then we'll have r minus 2 is greater than 1. To isolate my variable, I'm going to add 2 to both sides. When I do that, I get r is greater than 3. This is my solution set. So on my number line, I'm going to plot 3, one integer less and one integer more. Open circle at 3, shaded to the right, because that's where it is greater than. Awesome. Like I said, we're going to do the odds together, and you're going to go back and do the evens. So the next one we're looking at is number 5. We want to isolate our variable. So we are going to subtract 16 from both sides. You may notice your variable is on the right, and we're going to want on the left. So if you wanted to switch the sides and flip the symbol now, totally fine. Taking a look at this, we are going to have negative 20 is greater than or equal to 4x. Divide both sides by 4 or multiply both sides by 1/4. Negative 5 is greater than or equal to x. Switch the sides and flip your symbol. X is less than or equal to negative 5. Beautiful job with that. Be really careful now when you graph your inequality, because when we're dealing with negatives, 1 to the left, 1 fewer, is actually more negative, negative 6. So just be aware when you are graphing and labeling that. Closed circle at negative 5, shaded to the left, because that's where numbers are less than. Wonderful. Again, we're going to do the odds. You're going to go back into the evens. So number 7, we want to isolate our variable. So I'm going to change it up how I'm going to do it this time. I notice my variable's on the right, so I'm going to flip my symbol and flip my whole inequality to start. And just try that. see if I like that a little bit better. Add 2 to both sides. When I do that, I have negative 3n, do not lose your negative, is less than or equal to negative 3. Divide both sides by negative 3. Dividing both sides by a negative, what do you have to make sure you do? That's right, flip your inequality symbol, because that means we are taking the opposite relationship. So even though we flipped it in the beginning, we're flipping it again. This is called a double switcheroo. So n is greater than or equal to positive 1. Beautiful. Double switcheroo. Graphing, 1 is our boundary number, 2 is the integer above, 0 is the integer below. Close circle at 1, shading to the right because that's where they're greater than. Perfect. You're going to go back and do the evens at this time and pause the video, and then we will go over them when you're ready. Hopefully you paused the video. Let's take a look at number 2. Number 2, we end up subtracting 8 from both sides, dividing both sides by 6, needing to switch our inequality symbol to switch the sides, n is less than or equal to 1/2. So remember, we're going to label 0 and 1 because we want to label integers, and fractions are not integers. If you wanted to label in the middle here where that is, we could label it as 1/2. And we're shading to the left, close circle, because that's where they are less than. If we take a look at number 4, maybe you remembered that when you have a repeating decimal, we're going to write that as a fraction, so 18 2/3 plus 2k is less than or equal to 10. Subtracted 18 2/3 from both sides, ended up with 2k is less than or equal to negative 8 2/3. From here, I rewrote that mixed number as an improper fraction to make the math a little bit easier. Multiply by 1/2 on both sides, or divide both sides by 2. K is less than or equal to negative 13/3, or negative 4 1/3, which might help you graph this a little more. Negative 4 1/3, remember, is to the left of negative 4, so I'm going to have negative 4 negative 5, close circle, shaded to the left. And looking at the evens, 6 and 8 are the last 2 problems you had to do. So looking at 6, the first thing I did is I multiplied both sides by negative 4. Because I multiplied by a negative, I'm flipping my inequality symbol. So I get y minus 3 is greater than or equal to negative 20. Added 3 to both sides to get y is greater than or equal to negative 17. Remember, negative 17 is in the middle, but negative 18 is to the left and negative 16 is to the right. Close circle at negative 17, shaded to the right. And the last one, number 8, I wanted to show you 2 different ways, either by distributing first or undoing distribution first. Either way, you get x is greater than or equal to negative 18. Again, be very careful how you label your number line. Negative 19 is smaller, so it's to the left. Negative 17 is greater, so it's to the right. Close circle at negative 18 and shaded to the right. Great job, mini mathematicians. Fabulous work on solving multi-step inequalities, remembering when you switch your symbol. Good luck on your homework.